In the following presentation, I'll demonstrate how you can model and manage MEP elements with ArchiCAD's integrated MEP Modeler and using external applications, collaborate with engineers. As the BIM idea spreads worldwide, demand for modeling MEP systems is becoming stronger and stronger everywhere in the world. For the sake of better coordination and reducing errors caused by poor coordination between the disciplines, GRAPHISOFT developed a solution called MEP Modeler. This extension of ArchiCAD is fully integrated to the program, allowing you to model and control MEP elements in the architectural model context. On your screen, you can see how an architect usually creates the model. And this is how the building is really built. Although MEP systems are not part of the architect's responsibilities, avoiding the synchronization of these two may lead to conflicts and additional unexpected high construction costs. The GRAPHISOFT MEP Modeler enables architects to use familiar tools to incorporate 3D, mechanical, electrical, and plumbing model information to their building designs. The MEP tools are integrated into the toolbox as native design elements and are divided into logical groups like ducts, pipes, and electrical. As real BIM elements, all of these have correct 3D and projected representations and can be tagged, scheduled, or exported. There are two different methods to create MEP elements in the design project. One method is to build up the complete MEP system of the project by placing individual MEP elements one by one. Let's place some duct segments with rectangular cross-sections and investigate the results on the floor plan and in the 3D window as well. Placing an individual MEP element is similar to placing an ArchiCAD object. MEP objects are enhanced with smart connection hotspots to aid your work. All MEP elements have connection ports. These are represented by smart hotspots to which you can connect another MEP element. Unconnected MEP connection hotspots are displayed as diamond-shaped editable hotspots. The hotspots of correctly connected MEP elements are black in all views. These connection points greatly help your modeling work because when you connect a new MEP element to an existing network, the new element will automatically take the appropriate connection parameters, such as the shape, diameter, width, or height. Now we have to continue our model with a different cross-section, so let's insert a transition. The settings dialog is very similar to the settings of any tool. We also have an MEP section for special parameters. The General Settings page lets you define the length and insulation parameters of the duct. The GDL language allows these objects to behave intelligently and describe various geometry combinations in the same object. You can define the default length and insulation thickness and the system it belongs to. We will explore systems soon. The Visualization page lets you adjust pens, colors, fill types, and surfaces in the floor plan and also in the 3D view. The Connections page lets you define connection parameters. Here you can choose the desired connection type and also define its geometry such as connection, width, height, and wall thickness. Depending on the functional type, elements may have 1, 2, or more connections you can select in the list and customize one by one. For example, terminals usually have only one, ducts and transitions have 2, T and Y have 3 or more connections. We can also save favorites by often used parameter combinations to speed up the work. Please note that the element automatically recognizes the cross-section changes without any manual interaction. In this way, it's very easy to assemble the required geometry. Let's also place a bend now. By moving the cursor, ArchiCAD displays visual feedback indicating which direction the element can turn. For example, we can also go straight down. Of course, we can now continue with vertical segments automatically. One end of the duct transition is defined to connect two rectangular duct elements. We'll place some of those. Being real BIM elements, we can continue the work in any view, now on the floor plan. Let's add a duct Y element to the ductwork. The smart eye-shaped cursor is always at hand to speed up and ease the modeling work. Once we have a set of elements, we can also insert new ones in the middle, like a takeoff. Now we'll extend the system with some flexible ducts as well, which have special behavior characteristics. At first glance, it appears to be a regular straight element. But if we select it, additional hotspots appear in the middle. By using various functions of the PET palette and the editable hotspots, you can freely edit the geometry of the flexible ducts on the floor plan or in the 3D window. When the MEP Modeler for ArchiCAD is installed on your computer, the standard related ArchiCAD library parts will be extended with MEP-specific parameters to assist you with your modeling work. This is a generic basin, but if we take a look at the other side, small connections are visible. Let's have a look at the basin object. The Object Settings dialog has been extended with the Connections tab page. Here you can define or modify MEP connection settings. For example, we can define different parameters for the hot water, cold water, and wastewater connections. Let's activate the Pipe tool and click the hot and cold water connections. Notice that the diameter and the color of the pipes are automatically adjusted to fulfill the previously defined basin connection settings. Let's continue with the wastewater pipe to the basin in the 3D window. You can also create custom library parts which include these special connections. The result of including these in the custom library parts with the correct parameters is that these objects will behave similarly to the basin we used earlier. Normally, MEP elements are not standalone parts, rather they form functional systems instead. For example, pipes can deliver hot or warm water as well as wastewater. All these systems have their own characteristics, such as standard sizes or appearances. Now let's see how we can create and manage these systems. Much in the same way as MEP elements appear on the toolbox, the MEP commands appear in the Design menu after installing MEP Modeler. First, we set up the defaults for the automatic element creation. You can customize the behavior and defaults for all MEP types, such as ducts, pipes, and cable trays. The standard angles and sizes ensure that the placed MEP parts will meet the local standards. In addition, you can set how the collision detection detects the elements. Now, we'll open the MEP routing palette we can use to create automatically connected systems. In this way, we do not have to deal with switching between different tools such as ducts and bends, because the program takes care of all the connections and turns. MEP systems represent a group of MEP elements which belong together. MEP systems can have a uniform color code to ease the identification of elements belonging to the system. Element schedules and quantity takeoffs can be created faster as well. Here you can create new MEP systems or modify existing ones. Each system is dedicated to represent a ductwork, a pipework, or cable tray. We can define a custom fill type and also select various pen colors. These settings will override the values in the Tool Settings dialog if we create systems using the routing function. The routing function of the MEP Modeler enables you to create connected MEP elements with a series of mouse clicks, therefore greatly improving productivity and increasing efficiency in the daily design and modeling work. The floor plan view already contains some polyline segments. We'll use ArchiCAD's magic wand and the MEP routing function to turn this into a 3D MEP system. This is a good example of a mixed workflow. For example, when the MEP data comes from a 2D resource such as a DWG file, and the modeling is created in ArchiCAD. Once all the settings are appropriate, click the Start Routing button to start the routing operation. ArchiCAD's magic wand functionality traces the previously created polyline and creates a new MEP ductwork. It's immediately visible on the floor plan view. Please note that bends are created and adjusted automatically, so the whole system axis follows the polyline precisely. Let's see it in 3D. If we have such a long chain of elements, it would take too long to select the whole thing. To solve this, we have a special command in the Design menu called Select Connected Elements. Please note that the straight parts consist of multiple duct instances that automatically have the length we set up in the MEP Preferences dialog. Let's continue with another MEP routing example. Here, we'll use the routing feature to create some from scratch, which have more than one constant cross-section. Now, we'll change the size of the cross-section. You can freely change the dimensions of the ductwork at the routing palette without canceling the routing operation. The smart MEP connection ports will ensure seamless connection between the routed elements. You can also modify the routing construction method without exiting the operation. In this example, we will insert a slanted segment to the ductwork using a custom angle. Please note that because of the vertical height, some elements belong to the stories above the current one, so some segments are not visible. If we go up a story, we can find them there. Let's see the system in 3D now. As you can see, it's very easy to model a ductwork with different elevations, heights, or cross-sections. The GRAPHISOFT MEP Modeler provides a set of specific editing tools to help your everyday work. These tools and commands are similar to standard ArchiCAD editing commands, but they've been extended to reflect specific MEP requirements and therefore greatly improve your productivity. MEP-specific editing operations are available in the floor plan and also in the 3D window. The MEP-specific PET palette is always at hand and provides a set of operation-specific tools to speed up your editing work. Some basic editing operations, such as a move or stretch, are available in the section and elevation windows as well. Let's now see how easy it is. On the screen, you can see a duct and cable tray system. The rectangular segment is too close to the cable tray, so let's move it. As you can see, all PET palette operations are also available in 3D. It takes only a couple of seconds to modify this straight duct element in the 3D window. Even in 3D, ArchiCAD will automatically add extra ducts and bends to follow the modified route. Please note that while I'm editing an MEP element, certain parameters of the connected yet unselected MEP elements may also change as a result. After completing an editing operation, all modified elements become selected to provide feedback on the scope of the completed operation. If you select an MEP element and edit it, ArchiCAD will automatically add necessary elements like bends to follow the modified route. Now let's see the MEP routing feature in the 3D view. We will connect the two ends of the cabling line. Since we have a duct in between, we have to make the new cabling system jump over it. Creating a system in 3D is just as easy as creating a polyline in the floor plan view. Snap points and guidelines are always at hand to help find the needed points in 3D. Here we turn in the direction of the other part. Let's create a slanted segment so the cable tray will not be in conflict with the duct. We continue with a horizontal segment over the duct. Then we create a slanted segment to get back to the original tray level. With a double click, the system is done. The creation of MEP elements in the 3D window using the routing function greatly reduces the time spent for modeling. Thanks to the smart automated connection of MEP elements, designers don't need to worry about the integrity of the created MEP systems. The GRAPHISOFT MEP Modeler provides a unique functionality to check the engineering design of MEP networks against the architectural design of the project. This is called collision detection, and it's extremely valuable for architects to validate and check the design of the MEP engineers. The detection process can be initiated with a single mouse click on the floor plan or in the 3D window. ArchiCAD will start the process and check all MEP networks against the architectural design model. Once the detection process is complete, the collision detection dialog will display the number of detected collisions. ArchiCAD automatically creates markup entries to help the design review. All MEP collision entries are automatically added to the markup entries list. It takes only seconds to zoom and select a specific MEP collision entry in its design model environment. Adding notes to the collisions makes communication with engineer coworkers easier. The collision entry can be displayed on the floor plan and also in the 3D window to provide 3D feedback and help you make the most appropriate design decisions. Mechanical engineers and consultants who are using the 3D MEP application can send their work to the architects. The standard MEP parts will be converted into their equivalent ArchiCAD MEP library parts. ArchiCAD provides out-of-the-box translators which are optimized to import and export MEP data to external applications like Revit or DDS CAD. This open IFC system enables the members of the extended design team to use their own design applications for modeling. Using the IFC format as a common language, all parties can communicate and share the design while staying in the design environment which meets the local standards. This is an Autodesk Revit MEP project. It is exported by using the free improved ArchiCAD connection add-in for Revit MEP plugin. Let's open a previously exported MEP project with MEP Modeler for ArchiCAD. In this dialog, you can view and filter the imported elements down to those which are really important. In cases of large models, this is an effective way to limit the imported data, which reduces the file size and makes managing the imported elements easier. As with any other BIM files, IFC files have stories too. Now we align the stories to the ArchiCAD stories. ArchiCAD will start the conversion process. Once the conversion process is completed, the MEP elements appear in the model. As you can see, the ArchiCAD MEP project is fully equivalent to the original Revit MEP project. All MEP objects have been converted to their equivalent ArchiCAD library part. Let's have a closer look at the quality of the conversions. All elements which fully match standard ArchiCAD MEP parts, such as ducts, are converted to native ArchiCAD parts. For example, this pipe is now an ArchiCAD pipe with the settings coming from the IFC file. Those elements which do not have a matching library part in the library are converted to intelligent custom MEP parts. In this case, the geometry and the connections are retained. If we go to the Connections tab, we can see that the same intelligent connection settings are available as they are for any other MEP parts. This smart connection between Revit MEP and GRAPHISOFT ArchiCAD ensures streamlined collaboration between the mechanical engineers and the architectural designers. This concludes the ArchiCAD MEP Modeler demo. What I want you to remember is that this is an integrated solution inside ArchiCAD. There's no need for the architects to use any external applications in order to model MEP elements. The MEP parts are native elements. All display, editing, and listing features are available as they are for any other ArchiCAD elements. And last but not least, MEP Modeler combined with IFC-based open BIM workflows provides smooth collaboration between the BIM applications of the different disciplines. Thank you.